So what I'm going to do now is spend some time just walking through the new pages that we have within the B6200 GUI. These will be very similar on the single node product. For those of you that are familiar with the B6200, what you'll notice on the left-hand side is in the navigator view, we've got another entry. So just like we had the VTL, the NAS, and the replication, we now have another option under there, and you'll notice it's called StoreOne's Catalyst. Now, if you were to select that, you'll get this window here appearing, and you'll see the service sets at the top. In this particular example, you can see that this is a single couplet that we're using within the cluster. You'll notice at the top here that we have the service sets that are configured. So we have two service sets. You can see that we have the current node on which the service set is running. We can see which is the main node for that service set and also which is the failover node for that service set. And finally, you can see the current status of Catalyst. In both cases, it's in a running state. Now, this is exactly the same as what you'd see if you were looking at VTL or NAS or replication. So we do have a consistent view with Catalyst. So moving down to the bottom, here we can see we have the status window. Now on the status, what you'll see here is, first of all, its current status. So try and get that to the side. We've got a status of OK. We see the supported protocol version. So you'll notice that the initial protocol version for Catalyst is version 4. The reason why we're not on version 1 is because Catalyst is extensively based on top of the APIs that were developed for replication. And the reason we've done this is for stability purposes, rather than bring a completely new interface to play and having to completely qualify an entirely new data path from scratch. We actually started on a fairly solid grounding already. Moving down the screen, we'll see down here we've got a series of throughput values, and this will give you a quick snapshot of what's going on the box. So in the top half here, we have data jobs. So data jobs would include backups and restores, and we would get the amount of bandwidth that's being used and the perceived throughput. So if you're in a low bandwidth mode, for example, you may only be transferring 20 megabytes or so of data, but actually perceived throughputs, you could be in the gigabytes of data. So we'll give you both of those values for both the transmit and receive, so writes and reads. What we also then got down the bottom is the transmit and receive for copy jobs. So we talked about copy jobs quite a lot leading up to these pages, and this is where you would see how much bandwidth is being utilized for sending the data from one store to another, and how much bandwidth is being used for bringing data into your store. Now over on the right-hand side, you'll see we have the active sessions. So starting at the top, this will tell you how many data jobs you currently have open to this service set. So that'll be the number of backup jobs or restore jobs that are occurring. And then we've got the number of outbound copy jobs. So that's where we're sending data from this service set somewhere else. And we've got the number of inbound copy jobs. So that's the number of data copy jobs coming into this service set. And then finally at the bottom, we have the client command set connections. So this is just an indicator to show you how many clients currently have a session open with the appliance. This will give you really an indication as to how loaded the appliance is. Now moving on to the next tab across the top, we've got the settings screen. Now in here we can see that we have the option for client access permissions. This would allow you to specify that only certain clients are able to see certain stores. So very much like with NAS shares, you can specify which clients are able to see which NAS shares. You can also do a similar thing with stores. You're able to create client identifiers. Each of your media servers is then able to specify a client identifier when it makes the connection, and it will only see stores that it's been identified as having access to. Now, as you can see at the moment, this is not enabled, it's disabled. If we wanted to enable this, we could click the edit button at the bottom, enable client permissions checking, and then we would have a list of clients to provide access to. Moving on down, we've got the maximum current outbound copy jobs and outbound data jobs, current data jobs and inbound copy jobs. There are two things to note here. The maximum current outbound copy jobs is 48. Now what this means is concurrently we can have 48 copy jobs going from this D2D service set to another location. Now, if an ISV application wanted to queue up or wanted to request more than that, they would effectively be queued and they would be actioned as and when resources were available. Now, the maximum concurrent data and inbound copy jobs, that's a shared resource. So we can see here that into this service set, we can actually have a combination of up to 192 backup jobs, restore jobs, inbound copy jobs. They all share the same resource, but the limit is 192 streams. Now, finally, I'll draw your attention to the protocol port numbers at the bottom. For those of you with an eagle eye, you will notice that these numbers here, the 9387 and 9388 port numbers are exactly the same as the replication port numbers. That is by design. It is the same protocol. We do use the same port numbers. Now, although this is on the settings screen and there is an edit button, these values are fixed. They can't be changed in the current firmware. So you will see all traffic going over these two ports. Now, as we said, if we had client permissions enabled, then coming into this screen, we'd see here how we have a list of clients. Now, in this particular example, you can see here how we have the all clients option at the top. This is effectively your catch-all. It's your asterisk. It's the option that says, you know, anyone who claims to be this person will have access to everything. And then underneath, we can see we've created a client called DP Media Servers. This is just a string I've chosen. I use it for allowing my Data Protector media servers access to specific stores, so I don't have Data Protector able to see any of my net backup stores. Now, I draw your attention here over to this column on the right-hand side, which says Allow Store Creation. Now, this tick box will not be enabled by default, but for Data Protector clients, it's generally recommended that this is enabled. And what this effectively does is allows the client, when they're connecting to the D2D Store One appliance, to be able to create its own stores. So within Data Protector 7, when you're configuring up a backup to disk target, one of the options that you will get is the ability to actually create a store on the D2D appliance. Now, if your DP client has the correct permissions and has the allow store creation enabled, that will be successful, and it will be able to actually create the store from within the backup application, and even avoid the customer having to log in to the D2D to do this step. Now, this is only supported by Data Protector at this time. So if you have a net backup or a backup exec media server, there is no need to tick that box. And also, if you wish to prevent your DP customers, or if you want to prevent anyone else from creating a store on the appliance directly via DP, obviously you can disable that feature. And as I say, by default, it is disabled. Now, the next two screens will be very familiar to anyone who's used to the replication capability within the existing D2D products. They're actually carbon copy screens. So first of all, we have the blackout windows. Now, what this allows you to do is specify periods of time when you want to override the ability of any backup application to perform copy operations from this D2D. So this could be that you don't want the I/O overhead of these copy jobs running during this period. It could be that you don't want your network bandwidth to be utilized for copies during this period. Whatever the reason, you can come in here and create the blackout windows just as you would for replication. They are applied in exactly the same way. Again, it should be noted that these only affect outbound copy jobs. They do not impact data jobs or inbound copy jobs. Again, the next screen will be very familiar to you. This is the bandwidth limiting windows. Again, you'll see that this screen is a carbon copy of what you have for replication on existing D2D products. So in here, you're able to specify an overall bandwidth limitation that you wish to apply or you don't wish to exceed on the network. Specifically useful if you want to avoid copy jobs completely saturating the network, because they will try to use all available bandwidth if they're not capped. You're also able to specify different bandwidths at different times during the day using the windows at the bottom to edit those. So nothing particularly new there, but these are separate to what you have for replication. So if you're using both Catalyst and traditional NAS and VT on the same appliance, and you're using replication with the VT and NAS, you would need to configure your blackout windows and your bandwidth limiting separately for replication and for the StoreOne's Catalyst copies. Now back into the Navigator window, if we move down ever so slightly and expand out the StoreOne's Catalyst tab, you'll see under there we have the option of stores. Now just like VTL expands out and has libraries, and NAS expands out and has shares, StoreOne's Catalyst expands out and has stores. Now as you can see over here in the top frame on the right hand side, we have a list of all the stores that we have configured. So working across from the top, first of all, obviously we have the unique name for the store that the user has defined. We've got the version of the store. So as this is a first generation store, it's the first Catalyst release. They're version 1 stores. Now that becomes important when we add features to Catalyst in the future, and only new stores support new features. We've got the usual status information to show you that the store is online and it's not in either a creating or a deleting state. We can see when the store was created. Now we can see the number of items that we have within a store. And I draw your attention to this particular store at the top, that called Populated Store, where you can see here we have 384,000 items within that store. So each of those could effectively be a unique backup. Now we get asked many times, what is the limit? What's the maximum number of objects that you can have within a store? This tends to come from people that have reached the limit on NAS, or those that are usually limited by the size of libraries that they can create. And the good news is we suggest that you would easily be able to go up to 2 million objects. I wouldn't suggest going beyond 2 million objects purely because we haven't tested beyond 2 million. But I think you'll struggle to fill 2 million objects in a store, but certainly an individual Catalyst store will scale that size. Now the next column over, we've got the amount of user data that's stored, and the size on disk that's taken up. Now as you'll spot, the populated store here has an incredibly high dedupe ratio based on the fact it's taking up very little size on disk. But this is purely a test script I'm running on my particular machine. But as you can see, using the user data stored and the size on disk, it's very easy to calculate a dedupe ratio. It is just a factor of those two values. And then finally, on the right-hand side here, we've got the service set on which the store is configured. So this top section, very similar to what you'd expect to see for a VTL library. It's very similar to what you'd expect to see for a NAS share. So it's consistency in the views here. Now again, as usual, you'd see the create button in the top right-hand corner. And if you have a store selected, you'll have the delete and the edit options in the bottom. So moving to the bottom pane, down here we've got several tabs of interest. The first one is the store details. So in here, what we can see is we have the name of the store. So this is a unique identifier. Each store must have a unique name for the service set on which it exists. But then we also have a description underneath, an optional description. So this allows the user to provide a user configurable description that allows them to identify this particular store and its purpose. Moving down then, we have 3 log retention values. Now we'll come on to the logs in a few moments' time, but what I'll highlight here is by default all of these log retention periods will be set to 90 days, which means that we will keep a record of any data jobs, any copy jobs, be them inbound or outbound, for a period of 90 days. Now, if you wish to reduce that value for any reason, you are able to do so. So you can actually click on the edit button down in the right-hand side and edit those values. And you can actually reduce that to a low value. I believe that the absolute minimum is 1 day. But more importantly, you can actually increase that. So you can actually keep your logs for much longer, the maximum being 1 year, 365 days. Now, finally, the 2 options that we'll see at the bottom here are quite important when doing store configuration. So we see the primary default transfer policy and the secondary transfer policy. So the primary and secondary transfer policies, these are effectively going to specify whether you are going to allow pre-duplication to be done by the media server, or whether you'll insist that it is done in either the media server or the D2D appliance. Now, each of these options has 2 values. You can either select high bandwidth or you can select low bandwidth. The high bandwidth high bandwidth and low bandwidth refer to the link size that is needed. So high bandwidth refers to the fact that you need a very high bandwidth network to do the transfer, because we'll be doing all of the deduplication processing on the target appliance, on the D2D itself. Low bandwidth refers to the fact that the pre-duplication will be done on a different location, be it the client or the media server, and that only a low bandwidth network will be required to transfer the data. Now, as you can see, you actually would have 4 options when configuring, or 4 combinations when configuring a store. So in this particular case, we can see that our primary transfer policy is high bandwidth and our secondary transfer policy is low bandwidth. Equally, you could have a transfer policy of low-high, high-high, or low-low. Now, if you select high-high or low-low, what you're effectively doing there is forcing the store to be in a single mode. So starting with high-high, what you're effectively specifying here is you will not allow any pre-duplication to occur off the box. You're essentially saying that all the deduplication must occur on the D2D appliance. Conversely, if you were to select both primary and secondary transfer policies to be low bandwidth, you are now saying that you want all the pre-processing to be done on the client or the media server, and you will not accept any connections where the deduplication needs to occur on the D2D appliance. Now, in most cases, we'd actually expect the store to be configured with a combination, so either high-low or low-high. And so I draw your attention to the purpose of the default primary transfer policy, and particularly with reference to OST. So the primary policy is the one that will be used by default. So in the case of Net Backup or Backup Exec, when it's doing a backup, the mode by which it will decide whether to do the pre-duplication on the media server or not is dictated by the primary transfer policy. So if you specify in this case that it's high bandwidth, that means with OST that all the data will be sent to the D2D appliance in a hydrated form, and the D2D will be responsible for doing the deduplication on that data. Conversely, if you were to select low bandwidth for the primary transfer policy, that would mean that Net Backup or Backup Exec would be responsible for doing all the pre-duplication and only sending unique data to the D2D. So it's a useful one to know, specifically the primary transfer policy, specifically if you're using OST. So moving on to the next screen, we have the permissions. So if you recall, when we were configuring the StoreOnce Catalyst client permissions, we added a number of clients. We said which clients were able to create stores, etc. When we come down to the store level, now we're individually going to specify which clients have access to which stores. So in the top window here, we can see that populated store has been selected. We're looking in the bottom pane at the permissions tab, and here we can see that we have all clients have no access, but the DP media servers, they have access. So what that means is any backup application that connects to the StoreOnce Catalyst, providing the identifier string DP media servers, will have access to this store. Anyone else, regardless of what identifier they provide, will not be able to see this store. They will not be able to list items in this store. They'll not be able to create items in this store or delete items in this store. Now, the next 4 tabs are all reports. So the item summary, data jobs, outbound and inbound copy jobs, these are all reporting screens. So starting with the item summary, and specifically starting at the top with the filters. So by default, when you go to the item summary page, we won't automatically list out every item that there is within the store. Because as we talked about, there could potentially be 2 million objects within your store. And if every time you clicked on this link, we automatically started listing those items, it's going to cause a slowdown of D2D appliance, potentially impacting backup windows. So what we allow you to do is, first of all, if you want to look at the items and there's a specific item or specific criteria you wish to use to specify items, you're able to do that. So when you first come into the screen, you'll see the top half here. You will see the filter options. So here we can specify an item name. We can specify a period for when the item was created. We can specify a period for when the item was last modified. And we can also specify a tag list. Now, using a combination of those filters, you're actually able to reduce the number of items that come back in the report. So rather than listing out all 2 million objects, just trying to find the one object or the series of objects you're looking at, you can initially reduce down that list of items. Now, in this particular case, in this particular example, I didn't apply any filters. I did show all the items, and so down here we can see the list that's come back. So first of all, we got the item name. Now, the item name is what will be defined by the backup application. It will take the backup application's format. So Data Protector has a unique identifier that it uses for each backup stream, and that it will use that for the item name. Similarly, NetBackup and Backup Exec have their own formats for the naming that they use for the objects that they create. So in this list, in this column on the left-hand side, you will see their formats. Some of the naming used by the ISV applications makes sense, and some of them seems to be a random series of strings that make absolutely no sense. But needless to say, each of those will be unique. Again, just like the store version, we have a version of an object. So this will typically relate to the version of the store in which the object was created. But as over time, as we add new features in StoreOnce Catalyst, we may eventually see that we have objects that are version 1 objects, and we have version 2 objects and version 3 objects, etc. The next 2 columns are fairly self-explanatory. We've got the date when the object was created, and we've also got the date when the object was last modified. Now, just missing over the tag list, I'll come back to that in a moment. The obvious thing we have here is the size of the backup. As you'll notice here, on this test system, each one of my backups is only 1 megabyte at the moment. But with a backup, obviously, you would expect that to be many gigabytes in size, if not even terabytes in size. And then finally, we've got a metadata size. And the metadata is just an area of the object in which an ISV application is able to store additional information. It could be catalog information. It could be information used for debug. It's usually just a small amount of XML or JSON formatted text. But it just allows you to get a feel for how much additional data on top of the backup is being stored by an application. Now, coming back to the tag lists, a tag list or a tag is an identifier that's used by a backup application to give some sort of indication as to what the backup is. Now, for those of you that are familiar with things like Flickr or even within Windows, you are able to provide tags for documents. So you can say who the author was, you can specify particular keywords that you wish to associate with the document. So when you come to doing searching, you're actually able to find those much easier. Now, in the case of Net Backup, the kind of tags that it includes for each of its objects are, for example, the name of Net Backup, the version that it's used. It also includes the name of the backup policy that created the object or created the copy of the object. So if you wanted to filter by all of the or if you wanted to provide a filter so that you could see all of the backups that were created by backup policy number 1, you could simply do a search for the tag backup policy number 1, and you would see only the objects that have been created by that policy. Additional tags used by Net Backup are things like whether it was a full or an incremental backup, and also whether the backup was completed successfully or not. So these are all things that you're able to filter by. So in this particular example, let's say it's a demo machine, and so the tags we have here is a catalyst test object. So using any one of those 4 words, I will be able to get back just the items that match with those tag lists. So moving over to the data jobs. Now a data job is essentially any time you read or write to an object. Every time you open the object to do anything to it, be it the first time when you create the object and you perform the backup, or be it when you come to do a verify on the object or an import or even a recovery, there'll be a data job that will be logged. Now, just like you have with the item summary, you've got the filter options at the top, so you can explicitly filter down by the item, you can filter by status. A status would be, for example, that you're only interested in running data jobs, or you're only interested in data jobs that were cancelled or effectively failed for some reason. But most commonly, you'll be looking for backups in a completed state. You can specify which client identifier. So if I wanted to search by the identifier of DP media servers, I could specify a client. It's a substring match, so if you had client identifier strings using part of that, you'd be able to do that filtering down and get a list back of only clients or only data jobs from particular clients. And again, what we're able to do now is filter by a specific start time for the backup or the restore, or even the period at which the backup or restore finished. So using any combination of those filters at the top will allow you to specify or narrow down the report to only the data jobs that you were specifically interested in seeing. So going across the tabs at the bottom, again, we have the item name. So this is the item that was being created, or the item that was being backed up to or restored from. We have the status. So we've got whether it was successful or not, if it was completed successfully. If it wasn't completed successfully, then we have the status information. Now, status information may, for example, say link failure. That effectively means that during the backup, the network link was broken, and so the backup was unable to complete successfully. Another example could be that the target or the D2D was shut down whilst that backup was in play. In either case, you would expect under the status information to have the reason why the backup did not succeed successfully. Now, the next column, we have the data written. So this is the amount of data that was actually written to the object during this data session. Now, this doesn't necessarily correlate to the size of the object because you could be appending to an object. But in most cases, and certainly in the way that Data Protector and Net Backup and Backup Exec have implemented themselves, you will find in most cases that the amount of data written does equate to the size of the object when it's been finished. The next one I'll draw your attention to is the write throughput. Now, if you're in a high bandwidth mode and the D2D appliance has been doing all of the chunking and hashing, then obviously the amount of data that has been written will all have been sent over the network, and therefore the throughput will effectively be the total amount of data divided by how long that took, and that would give you a megabytes per second throughput. In low bandwidth mode, however, what you'll find is that you're only sending a fraction of the data over the network. And so over these 3 tabs, first of all, you will have the perceived throughput that was achieved. So again, that is the amount of data written over the time taken. But then we'll also show you the amount of bandwidth that was utilized to send that data over the network, which in low bandwidth mode would be a pure fraction of that. And finally, we do a quick calculation to tell you how much of a bandwidth saving you've actually made. Now, in all these particular examples I'm showing here, sadly, I didn't transfer enough data to get any meaningful numbers in these columns. But needless to say, this particular backup had a 1% change in there, and it was 2-to-1 compressible data. And so effectively, I only used up 0.5% of the bandwidth needed to do that particular write. And this does scale right up. So if the data amount had been written had been 1 gigabyte, again, we would only have used 5% of the bandwidth to be able to do that. Now, if you were doing a restore, then the amount of data read and the read throughput would also have figures in. What we tend to find with the backup applications is either you're doing data writes or you're doing data reads. But in the future, you may perceivably expect to see a backup job where verifies are run at the same time, and you actually get values in all 4 columns. Now moving over to the client column, this will essentially tell you which client it was that was accessing that particular object. So in this particular case, the client I had accessing it was a client called DataMover. So DataMover provided the client identifier, and it came from an IP address of 172.16.16.101. Now, when filtering at the top by client identifier, we're actually filtering by the text string at the front, so in this case, DataMover. The IP address that's following it is purely provided for informational purposes. It's not possible to filter by that. Now, finally, the 2 columns at the end are fairly self-explanatory. We got the start time for when the data job was started, and we got the end time for when the data job was completed. Now, all of these columns that we've looked at, this report is for data jobs such as backups and restores, but we do have exactly the same thing for the copy jobs. So the outbound copy jobs and the inbound copy jobs have very similar reports and very similar filtering at the top. So rather than spend time going over those, what I'll do now is we'll talk a little bit about the support tickets.